Hi students. So in this video I'll be talking about advantages and disadvantages of comprehension. So in my previous video I have talked about generators. So before I start with advantages, let me talk about the problem that we started with when we discussed about what is comprehension, then different types of comprehension. So the problem was we have an iterable and we want to perform some operation on each element of that iterable, and we want to create a new iterable using the modified elements of that previously defined iterable. So this was the problem and comprehension was the solution. So, and the example that we had chosen that time was, we have a string, let's say my string play with Python, and I want to extract each letter of the string, and I want to put all the letters in a list. Nothing but list comprehension. So yeah, and I have shown you that how to use list comprehension to solve this problem. Okay, so the question is, we can use for loops also. We will traverse through the letters of the string, and you will just extract each letter, and you will just put the letter at the end of an empty list, and we will keep on doing this. And if we want to add the condition, like we want to extract only the vowels, so we can also add the condition too. So let me do this. Okay, so we have to first define the empty list. So this is how we define an empty list. And for loop for letter in my string, then we'll add the condition that if letter in the list of vowels, that means A, E, I, O, U, and then if it is true, then only I will append this letter at the end of the list. Okay, so and that's all. So if we print the list, let me show you. See, only the vowels, and the comprehension portion was, and this was race letter for letter in A, E, I, O, U. Sorry. Letter in my string. If letter in the list of vowels, U. Yeah. So you can see that the only difference you can see now is this code is much shorter, much concise than this one. Okay, but there is also some advantages, I mean, of this comprehension over a loop, and that advantage is internal working. So how this for loop internally works is, this keeps on increasing chunk size or block size whenever a new letter comes, to make a space for that new letter. So in this for loop, internally it doesn't allocate memory at a time for all the elements. It just keeps on increasing each time on runtime. And in case of comprehension, it first allocates memory for all the letters. In this case, I mean, I am talking about this example. So it first allocates memory for all the letters. Then after, when the memory allocation is done, then only it keeps on filling up the memory block with letters. So in case of comprehension, memory allocation is done one time, and when the memory allocation is done for all the elements, then only it starts filling up the memory block with elements. So this is the difference, and this is the reason why this comprehension works faster than this for loop sometimes. Okay, so this is how these two code internally works. Okay, so this is one of the advantages, and other advantages I have already told you, that this code is much more concise, much more shorter. So yeah, these are the, and I can also show you the time difference, but for that I have to take another iterable, because length of this iterable is not much, so you won't be able to distinguish between the time difference. So let me take another iterable, my experiment iterable, range, let's say 1000 elements from 0 to 999, and let me define two functions, one for loop, and there I will define race, this will be my result, and for LE in my experimenter, race dot append LE. Okay, and after that I'll just return race. Okay, and another function, that is comprehension. Okay, return LE for LE in range, or sorry, we have already defined it, my experiment data. Okay, so you're done. So, and how can I check time difference, I mean execution time? There is a module called time it. I'll talk about this with more examples in my next videos, but let me show you the output first. Import time it, then print time it dot time it, and first we have to give this function, then from underscore main underscore import this function loop as if. So this is the function if we are calling here, and then we have to give number. This is number of iterations, and let me take 1000, and then for loop, and then for comprehension same. Okay, so if I just run this, see, so this is the time, execution time for loop, and this is for comprehension. Now you can see the difference. This loop is taking almost twice time than this comprehension portion. Okay, so I will talk about this function in detail with more examples in my next videos. Okay, so this is the advantage, one advantage of comprehension over a for loop. Okay, so does that mean we should always use comprehension instead of for loops? Actually not, because, so before that, let me give you another example, another problem. So when you deal with matrices, we use nested loops, right? So let me talk about a problem. So if we have a matrix, my matrix, like this, 1 2 3 and 4 5 6, okay, and I want to convert this matrix into a vector, or you can say I want to flatten this 2D matrix. So how can we do this? So we can use for loops, a nested for loop. So we'll first access each row, then for each row we'll traverse the elements of the row, and we'll just print it. We'll just take that element and we'll keep on putting the elements at the end of an empty list, as we have done before. Okay, so we can use for loops. So let me use comprehension here. So if my flattened matrix, this is my name, this is the list name, result list name. So how can I do this? So we are just extracting the element, we are not performing any operation on this element. So LE for, so what we are doing, we are accessing element from a row. So LE for LE in row, this LE is present in row, okay, and this row is present in a matrix, for row in matrix, so, or my matrix here. So this is how it is done, but there is a problem. Let me show you the output first. We'll get an error. See, row is not defined, and the reason is row, the sequence it is executed is from left to right, and when it encounters this variable name row, so it finds that this row is not defined, this row is defined here. Okay, so the solution is we have to just swap the positions of these two phrases. So we have to put this phrase before this. So internally how it works is, for each row in my matrix, so this is the two rows in this my matrix, for each row it will traverse through elements, and then it will keep on taking that element and putting at the end of the list. So this is how it works. So now you can realize that this is not that intuitive as we have done before. So the earlier version was much more intuitive. So this is the problem. Now think about this. We have used just two loops. So if we have multiple loops, now you can realize that we'll just keep on adding loops here. So this is problematic. This is not at all user friendly. It will compromise with, I mean, readability is much compromised here. So this is the disadvantage of comprehension over for loop. Okay, so actually depending on the circumstance we are in, we have to choose that we should we use comprehension or for loop. Okay, So that's all about advantages and disadvantages. And before I quit, let me talk about another concept, that is advantage of generator over a list. I was supposed to talk about this in my previous video, but I just totally forgot. So sorry for that. And let me talk about this in this video. I'll just talk about this. Okay, so I have not shown you the output. So if I just print it, flatten matrix. Let me comment out this. Sorry. Okay. And if I run this, see, so this is what I wanted. Okay, so that's all about advantages and disadvantages. Yeah, so advantage of generator over a list. So how list works is, it actually allocates memory for all the elements of a sequence at a time. So even if we are dealing with one current element of the sequence, it allocates memory for all the elements in memory. But how generator works is, we have already seen that generator returns, so whether you are using generator function or generator expression, it returns actually an object, generator object. And how generator works is, it uses a concept of call by need, or we know that lazy evaluation. So whenever the need of the value is failed, then only memory allocation is done and the value is returned to the caller, and internally it calls next method and it jumps to the next element of the sequence and it keeps on doing this. Okay, so this is how generator works. So at a time, memory allocation is done for one element for whole sequence, but in case of list, memory allocation is done for all the elements at a time. Okay, so this is the difference, and you can realize that generator is much more memory efficient than a list. I'll show you practically using get size of in my next video. So yeah, this is the difference. So now you can think of a problem that if we are dealing with a file that has, let's say, thousands of records, and suppose you are performing some operation on each line of that file. So at a time we are dealing with one row of the file, so there is no need of memory allocation for all the rows. So if we use list in this problem, so list will memory allocate, so list will allocate memory for all the rows, as you know. But if we use generator, it will use the current row and it will allocate memory for that, and for the next row it will just overwrite previous memory allocation with the next memory allocation. So this is how generator works. Okay, so that's all about today. In the next video I'll start with those two modules, get size of and time it, with more examples. For this code, I will upload this code on GitHub and I will provide you the links in description. Stay tuned, keep learning.